I don't know if I'm even in the right room in some ways. I love GDPR and it's very interesting, but I'm going to talk about something technical. I'm actually going to try to go through it a little bit quicker than I would otherwise, because actually there are some really big privacy questions. I don't know if we actually will get to them, but we'll see. QR code will take you to the presentation if you want to get, you can see it from there for your phone. So who am I? So I've worked for 30 years in the internet space. I've been one of those called garage entrepreneurs, lots of different companies, startups, consulting. But my passion essentially is with security devices and security specifications. And I've been involved in the IPsec work for 20 years. And I basically got asked, could I please do a security review of an IoT mesh protocol about 10 years ago. And I kind of got sucked in and down the hole. So what are we going to talk about? Exactly what kind of IoT am I going to talk about? Challenge of network enrollment. What is Anima? What's Brewski? That's my protocol. And what's Brewski for IoT? And then some details about how it works. So what is IoT? Can't do IoT without the picture of the Coke machine. I really like this one. I think this Coke machine may be restricted to one side of that yellow line and the kids on the other side. I'm concerned about some interaction that's not supposed to happen. Anyway, so I like to have three terms. Connected things, watches, headphones, heart monitors, mostly Bluetooth devices, but also the good old-fashioned SCADA things where there was actually wires to machines that were collected onto something. Connected. Not IoT connected. Then we have the web-connected things, the refrigerators that we've heard about, the teddy bears that spy on you. A friend of mine has a solar panel in his house. That's not his house. But this is his data, and he can only get to it by going to a cloud-hosted web system. So the power produced by his house is available only to him by screen scraping someone else's website. So the question is, does he really own his solar power system? I mean, how could he even know any of the things the last speakers talked about his data being controlled? He's not even essentially allowed to have his data, even though it's his device. So I'm talking about the Internet of Things, and we see this primarily, despite the belief that it started in the consumer space, we see, I think, the Internet of Things primarily in the industrial spaces, Industry 4.0, a whole bunch of stuff, and of course we see this, crazy home space. This group of vendors, there's a bunch of the different ones, they're really moving from the cloud connected only space into this is really an IoT home. Okay, so they're really moving in that direction. They're moving quite quickly. And I spent last week in Dublin doing interoperability with Brewski with a bunch of these people. And so that's really actually happening. It is no longer a cloud only kind of thing. It's now this is in your home and you actually apparently might really own it. So where does it come from? We came from this working group in the IETF called Anima. It's about autonomic networking, integrated model and approach. Anima, we always have really cool acronyms and we always pick the name before the words to fit the name, of course. What's it really about? Well, it's about the fact that it's really expensive for your ISP, especially of worldwide presence, to go and install equipment in new locations. You wind up shipping your most expensive, most senior guy out there because you want to get it done right. It has to be done probably at Sunday at 2 a.m. in the morning when everyone's exhausted. And really you're wasting a lot of your time and energy. So the idea is we're putting these rather big expensive routers, some of them are $100,000, into locations, and the actual physical installing and the hooking up of cables that can be done by, less senior people. If only the senior people could get reliable access to it, to the system once it's booted up. And traditionally that happens by a blue cable if you're using Cisco equipment and a laptop, okay? So the idea is, instead of doing that, let's actually build a protocol such that as long as one wire is hooked up correctly, or at all, we'll somehow get access. So why do we do it? Mostly it's profit, right? It reduces our OpEx, a great deal. And it means that our senior people get to do the configuration of the system on Monday at 10 o'clock after they've had 3 coffees, okay, rather than a Sunday morning. You get an out-of-band access is now replaced what used to be phone lines, literally with modems, even like a year or two ago, because if the internet's down, how do you access your equipment to bring the internet back up, right? So how do you do that? You use out-of-band access. So how do you do that if you are the phone company? And remember, the PSTN, at least in North America, it's gone. There's no copper across the country. There's no T1s that are real T1s. They're all turned into packets. They're all shooted across networks. So you can't get a piece of copper, a dedicated line or something from point A to point B. It's all packet. So if you're in that situation, you have a problem. That's what Anima deals with. And that's what Brewski deals with specifically with the bootstrapping. So these are the guys that would install your systems, okay? They're from a show years ago. This is Larry, Daryl, and Daryl. They're three brothers. Their parents were not so clueful about having picked unique names. And these are the guys that are going to install this equipment for you. And how do we get to IoT? Well, these are the folks that are going to be installing the IoT equipment at their home, right? And so we believe that with no aspersions, because she probably had a brilliant life with doing a lot of interesting things, but doesn't know how to configure the light bulb, nor should she, okay? So some Brewski terminology and icons, okay? It's really good to have pictures and explain. So we have the pledge. The pledge is the new device coming onto the network, okay? It's a duck because of a paper written 20 years ago by Ross Anderson over here at Cambridge, where he described the resurrecting duckling. Well, what we're doing is not quite the resurrecting duckling, but it's pretty close, but calling them ducks is great. And if you know a little bit about psychology, ducks will imprint on whatever looks like their mother at the right time. And the biologist discovered, I forgot his name now, essentially that they would imprint on his boots and consider him to be their mother if they saw his boots at the right point. Our system's a little more secure than that, fortunately. We have a manufacturer builds the devices, and then he signs them with a signet ring, okay? The voucher, I'm still looking for a better icon other than stamping a passport, but essentially it's like a visa. And we have our joint registrar, and I'm still looking for a better icon than the passport guy, but that's essentially what he is. So how does it work? The device comes along with an identity built in at the factory. There's a bunch of different interesting ways to do that. We don't have to talk about that here. We don't have time. An anchor is installed, so a trust anchor is installed at the factory. The device is deployed, it leaves the factory, it wanders down the stream, and it gets there. And essentially what happens, it says, hey, I'm a device, are you my network? And the network says, hey, you're a device, it looks like you're from this vendor. I'll go talk to your vendor, and I'll find out what happens. So this is how it works. It says, hey, are you my mommy? Goes out, actually says it to this guy, and this guy realizes it. And this guy makes a signature that says, adoption papers, this is your new owner. This is who you belong to. Hands it back to the new device. Now there's some plumbing complicated things here, because this guy has no internet, okay, at this point, and he has to ask this guy to talk to this guy, and there's some back and forths involved. End result is the pledge has a signed statement from an authority they trust by construction that says, your new owner is Joe. Joe's the owner, you're done. Next thing they do, of course, is install another set of credentials. So Joe provides the pledge that says, oh, you're Joe's fridge, or you're the IET building's light bulb 12, okay? Goes up there, that's where it goes. This is what a voucher looks like in JSON. It's digitally signed. There's versions in Savoy, if you know what that is, which is a constrained version, and we're trying to make this all work. And there's a lot of interesting properties there. One of the interesting problems is many of these little devices don't have clocks, or they won't have a clock or the correct time until things happen. So there's some back and forths. There's other problems. We have a nonce for freshness, so that we know that it was this time the device enrolled. One thing I'll mention is the device doesn't do this every time it powers up. The device needs to save its identity between things. So this might happen the first time you buy it. It might happen if there's a catastrophic firmware update, you reset it to the factory defaults, or it might happen if you sold the device. So where are we at? We have been through an IETF level Internet Engineering Task Force. Working groups have working group last calls, which is basically, does the small group of people in the room agree this is done? And we've been through that process, and we then got some cross-area review. Got another one this morning. So 43 is not correct. I don't know what number, but about 43 issues. A great deal of these issues, unfortunately, were what about this, what about this, what about this, what about this? And most of them are going to be replied with, I'm sorry, but we'll be boiling the ocean next week, and we're going to restrict ourselves to the problem of very narrow scope of deployment of equipment. It's part of the Bootstrap process for the 6TISH, which is an industrial, Industry 4.0 kind of deterministic mesh network protocol. It's part of that. And as I said last week, Fair Hair Alliance is actually doing interop testing on this. And I'm told, because no one's officially told me, that it's part of the thread group at this point. I think I know how to do it trivially over Wi-Fi. Some people disagree and say you're wrong. It looks like we're going to have a bigger conversation about this. People don't like having this massa, and there's another group that's wants to use it for something completely involving distributed denial of service attacks, and I don't understand that. What does it cost? Well, you got to put an individualized ID in each device. 10 years ago, that makes people freak out. No, not so much. There's quite a few people, quite a few vendors who have ability to do that. There is this thing called a PUF. I keep forgetting what it's called. Predictably unique function. Pardon me? Physically unclonable function. Thank you. I always remember PUF, but never the thing, which makes it really hard to Google, because you Google for PUF, you get all sorts of wrong things. Point is that it's a thing that probably, for instance, you turn on a RAM chip and some parts of it tend to be ones and zeros without any power, and that turns out to be repeatable over things. And of course, normally the first thing you do with a piece of RAM is you clear it all to zeros, but there's some stuff in there, and there's other ways of doing it. You can put it in with JTAG. You could just outsource it to a trusted platform module, who all it's really done is you've outsourced the problem to someone else, but presumably someone else who has more money and time to deal with that problem. Got to do some crypto operations in the device. That's probably a good thing anyway. If you heard this morning, it was in a talk, not the plenary, we got to have the ability to have cryptographically signed updates. So if you can't do some crypto operations in the device, you probably shouldn't be using that device, because it's not going to be sustainable and updatable. The most difficult problem is that the manufacturer has to operate this thing called the MASA, Manufacturer Authorized Signing Authority. Okay? The manufacturer could operate it themselves, but as implied by the word authorized, we anticipate that 90% of the manufacturers are probably going to outsource this to somebody. That device is going to live in the cloud, and each time a new device is activated, so you brought a light bulb home from Tesco, the light bulb is in some form going to call home once and say, I am now Joe's light bulb. So there's a lot of huge issues there. What if the light bulb has been sitting on the shelf for 5 or 8 years and the manufacturer's gone out of business? Now what? What if you bought a router 15 years ago from a company in my town called Nortel? Right? It's gone, right? It doesn't have to be light bulb manufacturers. It can be big worldwide companies. They disappear. So at which point, what do you do now? Well, one answer, if it's a big router, is you've got to send out the highly expensive person who sets it up manually. If it's the light bulb, well, I think you're returning it, and I think it's going in the landfill at this point. And we don't have another answer for that part. But what if it's somewhere in between? A washing machine, right? I bought my washing machine from a company called Sears. I don't know if you have it here in the UK, right? So I bought the extended warranty because they're really good for, everyone buys their appliances from Sears in Canada, and no one buys dresses from there, which they would think is unfortunate. Well, guess what? Sears is out of business 2 years, and I don't have a warranty on my washing machine. And if it called home and I moved it to a new house and had set up Wi-Fi again or something like that, I might have to go through the Bootstrap process. Now what am I going to do? okay? Oh, I bought my dishwasher as well from them more recently than that, and that was $1,400, and I will not be happy if I had to do that again. So that's a real issue. Can I resell it? Well, when it gets resold, you have to rekey the machine. Will the manufacturer be allowed to decline my resale? Think about that. The things that you often sell to other people that the manufacturers really don't like you to do that. Mobile phones, TV sets, cars. They don't want you to buy a new car. They don't want you to buy a used car. They want you to buy a new one, okay? So there's a real big question, and maybe it'll fit into this room a bit more. Finally, the owner must operate a registrar. Not a big deal for an ISP and enterprise. No big deal at all. Not a big deal for Industry 4.0. They love it. I now have a list of all the devices that have been activated in my plant. That's something they didn't have before. And they know the serial numbers and the model numbers and maybe even the firmware versions of them, all in one database. Okay, that's like some plants, that's like $1 million activity to go and write them all down to find out if you're vulnerable. Well, does it work in the home? Any of you know how to run a registrar? Exactly. I'm not even sure where to put it in my home. On my home router, but it kind of blows up now and then. On my home NAS, yeah, well, that may be a good idea. Not on my laptop, because it leaves my home. So where exactly? In a light bulb? Some of them are powerful enough, and they have power, right? So there's the question. It's something we're working out. I'm actually working on a different project, completely different than this, but it turns out that we're building a home IoT firewall, and it turns out that that's where we're going to need to run the registrar. That's it. That's all I have today. Ducks and signet rings.